Hi there, folks. Today we're looking at areas of parallelograms and triangles. And a parallelogram, really, we already know the area of a rectangle, and a parallelogram is not really any different. We just, instead of calling the rectangle length and width, we're going to refer to it as base and height. And when we refer to it as base and height, we make it a little more generic. It applies to more than just rectangles now. So a rectangle, instead of length times width, like maybe we did in elementary school, we're going to do base times height. Really, it's the same kind of thing. It means the same thing, and it's going to yield the same result. All right, so area of rectangle is base times height. And then area of a parallelogram is also base times height. And see, the reason we can't call it length and width anymore, if we refer to it as base and height, when we measure the height, we're measuring at a perpendicular angle. All right. And so whenever we take a measurement, if we want to measure the height of something, I have to measure directly from one end to the other. I can't go on an angle measuring from one end to the other. Think about measuring your own height. If I were to measure my height, I have to go directly from the ground to the top of my head, and that is considered my height. I can't measure from like the corner of the room all the way up to the top of my head on an angle and say, oh, I'm 18 feet tall. Look at me. I'm huge. I'm a giant. All right. I have to measure directly from the thing I'm measuring, which is the ground, to the top. And so whenever we measure the shortest distance, we measure directly. We're talking about measuring at an angle that's 90 degrees. Okay. And so when we think about that back in the form of a rectangle, well, rectangles, this is already true for the sides. Okay. There's already a right angle here. And so the actual side is the height, which is why we were able to do length times width in the past, okay? It's really base times height. It just so happens that the height is one of the sides. For a parallelogram, the height's not one of the sides, all right? It's a separate line that I have to draw in here, okay? And so we just do base times the height. So if I take a look at this first one, again, the area of a parallelogram is the base times the height. So really, it's just a matter of determining which is the base and which is the height here. And so again, when we take measurements, we measure directly. Okay, we have measured a 90-degree angle. And when we look at the measurement that's happening at a 90-degree angle, that's our height. That's the 4 inches. And then to determine which of these is the base, look at which of those things that 4 inches is measuring between. It's measuring from this side to this side, which means those sides would be considered my base. And it doesn't matter which of those sides I can consider my base because, again, in a parallelogram, the opposite sides are congruent. And so the base of this one is the 5 inches, whether you look at it at the top or you look at it at the bottom, okay? But the height has to be measured from one base to the other, all right? So when you look at which sides I'm measuring from in terms of the height, that tells me which of these is going to be my base, okay? And so the area here, let's see, that's going to be the base times the height. So the 5 inches times the 4 inches. And you don't have to write the inches in here, but just to show you how the units turn out, just 5 times 4 is 20. And the reason it's inches squared from a mathematical perspective is inches times inches is inches squared, okay? From an actual measurement perspective, when you measure area in terms of inches, you're measuring square inches. You're measuring little blocks of inches that are 1 inch by 1 inch, okay? And so we call it a square inch, okay? If I look at the next one, once again, I have to look at the height here. I can see that the height, the measurement that's kind of going off at a 90-degree angle is 3.5, and it's okay that it's outside the parallelogram. That happens sometimes. It'll happen with triangles as well. But again, we're just measuring from one side to the other, and we have to measure the shortest path. And the two sides I'm measuring between are these two short sides, which means this is my base, okay? And again, when you think about that, the only way to measure that is I have to kind of extend this side out in order to get that actual height, okay? So once again, the area is the base times the height. This time I won't write the centimeters this time, but you could. And when you multiply that, that gives you a 7. And the units are going to be centimeters squared or square centimeters. Okay? If I look at this one, it says find the value of x. So I want to find the value of x this time. And x is measuring the height of this thing. However, I don't know what the area of this thing is. So like if I think about using that x, I would say, hey, the area is the base times the height. So if I'm looking at this x value as the height, Well, then the base that I'm talking about, the value that x measures from which side to which side, is the 9.4, okay? So the area for this one would be the 9.4 times x if I want to write it base times height. If I want to, again, the order doesn't matter, of course, but if I did base times height, that would be the area. The problem is I don't know the area or x. And so look at the other measurements that are given. Notice there's another measurement that's kind of set at a 90-degree angle, which is this guy up here. So that one is also a height. But that one, if you kind of rotate it or turn your head sideways a little bit, all right, that one is measuring the height between the other sides. And so for this particular parallelogram, we could say the area equals the base times the height. If I look at 9 as the height, well, that's measuring from the 13-meter side to the other 13-meter side. So I could use 13 meters as the base, okay? So again, base doesn't necessarily mean at the bottom. Typically, we try to draw it that way. But you can easily rotate this figure, put 13 at the bottom, and now you can see 9 is the height, okay? And so for this one, I can actually find the area without using x, and then we'll use the area to go back and find our x value. So let's see, that's a 117, and that's square meters. And notice it didn't ask for the area. That's great. It asked me to find x. Well, back over here, if I look at this equation, now I know the area of the parallelogram. It's still the same parallelogram, so this should give me the same area. So 117 equals the 9.4 times x. I can actually solve this for x. Now I divide each side by the 9.4, and that gives me approximately 12.45. And that's going to be in centimeters, okay? And so again, I used different measurements, a different height and base to come up with the area of this thing, and then worked backwards to find the value of x, okay? All right, area of a triangle. Area of a triangle is 1/2 the base times the height. And the reason we talk about area of parallelograms and triangles together is because if you cut a parallelogram in half, it gives you a triangle. So think about the formula we just did. Here's a parallelogram. If I were to cut this parallelogram in half diagonally, you see that it gives me two triangles. It gives me one triangle up here and one triangle down here. And those two triangles are actually congruent triangles. We've talked about that, and we've proven that in the past. And so if I have a parallelogram broken into two congruent triangles, it means the area of one of those triangles is half the area of the parallelogram. And that's where this formula comes from. It's 1/2 the base times the height, all right? Because a triangle is half of a parallelogram. And really, any triangle can be drawn as a parallelogram if I draw a congruent triangle next to it in kind of the right way, all right? And so keep that in mind. Like this one, I could easily extend this guy out like this. And if I made that parallel to this guy down here and then extended a line up this way that was parallel to this guy, what I've done is I've created a second triangle that's identical to the first one. And so when you think about this, that's base times height for the area of the parallelogram. Well, the triangle is half of that, so 1/2 the base times the height. So that's where that formula comes from, okay? So it's the same thing, but only half. So we look at this guy again, find the area of each. And once again, it becomes really important based on the height that I'm given here, which of these things is going to be the base of my triangle. And so for this one, if you look at the 10, that's the measurement that's being measured perpendicularly. So that is my height. And so now you have to ask yourself, well, that's measuring the height from what base? And this is a little bit trickier than it was with the parallelogram. With the parallelogram, I was measuring from one side to the other. Now I'm measuring from one side to the vertex. And so when you look at this, like look at this one, I'm measuring from this side to the opposite angle. And so the question here is, I'm measuring from which side to the opposite angle? And for that, it's this angle and this side, okay? And so really, this one is not written in or it's not drawn in the way that we're used to. We would have to kind of rotate this thing to put the 4.2 on the bottom, and then it would be a lot easier to see that 10 is the height, okay? So we have to kind of just think about this a little bit and kind of rotate this thing in our head if we want to put that 4.2 at the bottom. So just think about rotating this thing around until you have the 10 lined up as a height. It should be pretty obvious which of these is the base then, okay? So just make sure you're using the right value for the base. And so for this one, Once again, the area is 1/2 the base, which is 4.2, times the height, which is 10. Okay? And I multiply this out. Let's see, that's going to give me a 42 times 1/2 is a 21. And again, that's square meters. Okay? So again, just make sure you're identifying which one is the actual base. If I look at this one's a little bit tricky because of the units. I've got 12 feet 2 inches and 13 feet 4 inches. And it's obvious which one is the height and which one is the base. So I just want to do area equals 1/2 the base times the height. But the problem is that my base is written in 2 different measurements, and so is my height. You're going to have to convert this, okay? And so for this one, this is 144 inches plus the extra 2 inches if you convert the feet. So that's actually 146 inches, okay? So that's what I'll use for my height. I need this as one measurement. And it makes more sense to go to inches than it does to feet, so I'm not dealing with decimals. Same thing down here, the 13 feet, if I kind of take it off to the side a little bit. The 13 feet would be 156 inches, plus an extra 4 inches would be 160 inches. And so that's my base. Okay, so now by just writing this thing in terms of inches, now I can actually plug this in. It would be difficult to plug something in and multiply feet and inches together. Okay, so convert it to 1 unit first. And now let's do this multiplication and some division. And that gives me the area as 11,680. And that's going to be square inches. Okay. Now the thing that becomes tricky here is, well, what if we wanted this in feet instead? Well, if you wanted this in feet, you'd either have to convert each of these to feet, or if you look at the final answer, think about this in terms of factor label. If you think about a square foot, you do it this way. 1 square foot is like 1 foot by 1 foot. Think about that in terms of inches. It would be 12 inches by 12 inches, which is actually 144 square inches. So 1 square foot is actually 144 square inches. So if you wanted to use factor label here, 144 square inches is the same as 1 square foot. And so really it becomes a division problem here. It would be 81.1 square feet. Okay? And again, you could do that by converting each of the original measurements to feet instead, and then plug it into your area. Okay? The reason it's better to do it this way is because if I convert each of those measurements to feet right now, they're going to be rounded off decimals if I do them as a decimal. By doing it in inches first, I get an exact answer, and then I don't have to round off until I actually convert to the feet. Okay? If I look at this one, kind of piecing this together, remember our area addition postulate. When we talk about area addition, we can break this thing into shapes that we understand. This overall shape is not one that makes sense to us, all right? But if we break this into pieces that we can find the area of, then we can just add up the different pieces of the area. So this one, I would draw a line kind of across here and essentially split this thing into a square and a triangle. And so if I look at this, because this guy, we have these dashes, this is also 6 feet. This is also 6 feet. And now what's going to happen is this guy is also going to be 6 feet. So I've created a square. And I've also created this triangle up top, and this triangle has a height of 8 feet. And so I just find each of these individually. I say, okay, to find the area, it's really the area of that square, which is the same as a parallelogram. That's base times height, plus the area of the triangle, which is 1/2 the base times the height. And now I just need to simplify this thing. And again, you could include the units as you go. It's actually easier just to leave them off until the end. And it was square feet. That's it. All right, so break this into pieces that we know how to find the area of, and then add them all up. If we look at this guy, same kind of thing here. Notice I have a parallelogram with a triangle kind of tucked off to the side there. And so what I need to do is I need to find the area of the parallelogram and the triangle separately. And so first thing I want to do is maybe use some segment addition. And when I talk about segment addition here, you know that the opposite sides of a parallelogram are congruent. So this side is also 25 inches, which then means that this piece over here, just the side of the triangle, or the base of the triangle here, is going to be 40 minus the 25, so 15 inches, and that's where I'm using segment addition. And then from here, if you kind of think about this, the height of the parallelogram is going to be the same as the height of the triangle. You could bring that guy over here. That's also 12 inches, okay? And so now I just find the height of each of these individually and kind of add them together. And so for this one, the area equals the area of the parallelogram, which is base times the height, plus the area of the triangle, which is going to be 1/2 its base, which is 15, times its height, which is also 12. And then it just becomes a job for my calculator a little bit here. I do the 25 times the 12. I mean, I guess you don't need a calculator on that one. And then the 15 times 1/2 times the 12. And then add them together. And again, I left the units off until the end, but the units on this one are going to be square inches. And that's it. All right. So area of a parallelogram, just like a rectangle, just like a square, is base times the height. A triangle is actually half a parallelogram, so its area is 1/2 the base times the height. All right. And it's just a matter of determining which one is the height, and then based on that, which one is the base of this thing. You might have to rotate the figure or kind of rotate it in your head at least. Okay.